rushing around.
Fleas and greetings, puppies and kittens. I am doing another Q&A with one of my patrons. We've done a couple of these before, and I'm down to chat with people when we agree, and I'm also pretty good when we don't agree. If we're going to have one of those kind of conversations, we can do that. So, Keegan, how you doing?
Good, mate. How are you?
It's all right. It's all right. Holding together so far.
That's good. Must be crazy over there at the moment.
Oh, it's I'm trying to remember when it wasn't.
My brother was trying to go over there to Texas, but he's saying that Trump's making it really difficult for him for some reason.
Yeah, I'm actually concerned about traveling internationally myself, even though, I'm a citizen and even a privileged white boy, and I'm still worried about trying to get back into my own country.
Yeah, I don't blame you.
Yeah.
So what I wanted to talk to you about was this was actually a comment that was made on one of your videos, and it was a really long comment, but it sort of really helped me click into how evolution works. I know you're always saying that things never turn into fundamentally different types of things, and this really helped. So I took that comment and I've done my own research and refined it and stuff, but I just wanted to run it by you because I wanted to make it into a video. And I just want to make sure that I've got it right. So the first part of it says, evolution does not deal with the existence of the universe. It's the explanation to diversity of life on our planet. Monkeys did not turn into humans. We are monkeys. It's like saying you can't see a bird turn into a duck. And so we'll use humans as an example of how things do not ever change into fundamentally different kinds of things. So the first one is the domain, eukaryota. Do your cells have a nucleus? Congratulations, and you're a eukaryote. Everything ever descended from a eukaryote is a eukaryote, and evolution demands that this never change. So do individual eukaryote cells still exist today?
All of ours, well, that's actually a fair statement. I would say that all of our cells are eukaryote, but that's not actually true, because nearly half of the cells in your body are not yours.
It's like mitochondria, right? Is that right?
Well, in that respect, then all of your cells actually possess a cell that is not yours.
Yeah.
But I was going to say that in our digestive tract and all of that, I mean, we carry about an awful lot of every eukaryote, I think, well, certainly the animals carry around an awful lot of bacteria, prokaryote cells, which assist us in digestion, among other things.
And it's completely unique between each individual, isn't it? The gut biome.
Well, I don't know about that, so I don't know how to comment on that. I can tell you that all of our cells, as you pointed out, have mitochondria in them, and that's technically bacteria with their own independent DNA, living in a symbiotic relationship. And quite a lot of your cells are not. Quite a lot of the bacterial cells in your body are not within your own cells. They are the flora of the gut and other things. Yeah. And so, but your question was, do eukaryote cells still exist today? Well, of course,
as singular cells,
as singular cells, yes, there are unicellular eukaryotes still today, and interestingly, the most primitive of them are without mitochondria.
Oh.
Yep. So you do have independent eukaryote cells that do not have mitochondria, and they get along. They survive okay, but when you have mitochondria, there is an advantage, so that the system has more energy to spend.
Yeah, of course. But so, like, these singular eukaryote cells now, do they ever show evolutionary change that we can witness to show them becoming, say, because the next one is kingdom Animalia? Do they ever show changing into an animal cell, or?
There's no such thing as, well, you can say there's an animal cell, but animals by definition are multicellular. So metazoa, it's not just that the cells have, and we do have in choanoflagellates, we have some examples of what this looks like, where choanoflagellates will cluster together and they can take on the appearance of epithelial cells. Am I saying that right? It doesn't sound right. But one classification of animals would be kingdom Metazoa. Kingdom Animalia is also Metazoa, or it's epithelia, because the choanoflagellates do form something that looks like epithelial cells. Individually, they look an awful lot like sperm cells wearing skirts.
Oh.
Yep. So they are. It's the basis of what, if you wanted to take animal form down to a single cell and see what it looks like, then it looks like a sperm. And in the case of choanoflagellates or epithelial cells, they are decorative sperm. They're sperm with a little skirt. And it was fun when I was at the Reason rally. I remember this couple of young Earth creationists, who said, "I didn't come from no glob of goo." And I'm like, really? All the rest of us did.
Yeah.
How did your parents make you?
Exactly. Yeah.
Or was there somebody else that made you rather than your parents? Because everybody that has a mom and dad, we all came from a glob of goo.
Yeah, 100%.
He didn't like that. It's like when the guy told me, he says, "Well, you think you come from apes? Where's your tail?" And I have to point out, apes don't have tails.
Apes don't have tails. Learn. That was Hoven's son. You said that too. I love that video.
The first time I said it, it was to a canvasser who showed up at my door to come into my house to talk to me about Jesus.
Learn taxonomy. That's what you said to him.
Yeah.
So both animal and plant cells, they both have mitochondria. Is that correct?
Yeah. So what appears to have happened is as I said, the very simplest, most basic, and there's not many of these types of eukaryote cells don't have mitochondria. So there was somehow a formation of eukaryote cell structure, and we know that there's multiple endosymbiotic events, but even the two prominent ones are that. And this could have even led to the formation of eukaryote to begin with. But once we had a eukaryote cell, they enveloped somehow a one or two mitochondria. And so the mitochondria is a form of rickettsia bacteria. And so that they develop this symbiotic relationship where once the bacteria are consumed, they're not destroyed. They're basically paying for their room and board. And the advantage is with the host also that hey, we've got so much more power because of this, so let's work this out. And then their reproduction is in the same cycle.
That's where I get screwed up, because I'm like, why would the reproduction allow for the mitochondria to continue being? Yeah, it's bizarre.
So the way they reproduce is so fortuitous in this that it allows them to just continue. Like you have now one eukaryote becomes two, and the two that inside it have become four, even though they're prokaryote.
So the mitochondria has separate RNA or DNA to the rest of the cell, right?
It's got its own DNA, and it's the configuration is different.
Yeah.
So in eukaryotes, the DNA is in a double helix, of course. But and then the complicated way that they're all packed together is like when you keep winding a rope that is already wound. I mean, the way you make rope is when you take a bunch of strands and you wind them in a particular way. But then with DNA, it's like when you take a rope and continue to wind it.
Mm-hmm.
You've noticed how the rope will
double up again,
and then it takes on these contorted forms. DNA does the same thing. But where DNA has this double helix and this complicated pattern of held together by histones and such, with bacterial DNA, it's more of a ring. It's not the big chromosome. It's the
right.
It's not the same type of chromosomal pattern that we have with eukaryotes, but it described relatively simply as a ring.
Right. Because one of the things I like, so the difference between animal and plant cells, they both have mitochondria, both are eukaryotes. So do we share mitochondria?
So what ended up happening is that we have this first endosymbiotic event, and then there was for some time we have cells that just have the mitochondria.
Mm-hmm.
And they, of course, would be the ancestors of both animals and plants. But on the side that branches off to plants, they have a different and the second endosymbiotic event in which they also envelop cyanobacteria, which becomes chloroplasts.
And that's how they photosynthesize. And
yes,
okay, right, yeah, because one of the big plants have rigid cell walls was one of the biggest differences between animal and plant cells. But then I said, well, what about skin cells? They appear quite similar because they have rigid walls. So I guess there's obviously exceptions to the rules.
Yeah, there's generally the prokaryote cell type, then you have the animal cell type and the plant cell type. But of course, there's variants of these. This is just the three most basic. If you were going to divide it up into two divisions, well, then plants and animals are the way you would look at all eukaryotes, but then you have to consider that prokaryotes need to be considered as well. So and then anything that you divide into more than just three, well, now we're talking about subsets of each one. So it's the basis of animal cells or the basis of plant cells. And even when you look at fungus, fungi, it's not different enough to warrant in most people's illustrations a different type of cell for fungi than for animals or plants.
I've read that we are closer to fungi than many other plants.
Yep.
Right? Yeah.
And I've got a couple of comments coming up here. So Axel Van 8080 says, does Aaron Ra do taxonomy, or did he ever change to cladistics? Well, cladistics is a form of taxonomy. Linnaean taxonomy is based on a rank system, and it's entirely based on morphology. So how you classify things by the characters that it has. However, cladistic taxonomy or phylogenetics also is twin nested. So the second nest is in genetics. And so that takes the situations where in fossil animal forms, we don't have their DNA and we have to base all of our classifications on their physical characteristics, their morphology. But then when we have DNA for existing representatives, we can use that to confirm or correct what we'd initially said about taxonomy in the old Linnaean construct. And then we've got somebody else here that says, I read that one. Trevor in 369 says, Aaron Ra, from what I've read about natural selection to one of Charles Darwin's, what was it? In one of Charles Darwin's books, it was way too interesting to avoid, especially when compared with the evidence. It's way too beautifully. I guess that's way too beautiful, actually. Way too beautiful. That's a way to put it. It is, I think, beautiful. It's certainly intricate. And there's a lot of religions that like to try for the thing about being connected to everything. And so Buddhism doesn't achieve that as well as phylogenetics does. And then Explode 2006 offers $4.99. Thank you very much for that. And says, creationists argue the four corners of the earth from the Bible is just metaphor and not literal. Your thoughts on this? Well, when it says corners, as I understand it, it's mistranslated as quadrants. So the earth, according to the Bible, is a map that is basically set on a plate, like a disc. So you draw a map and you put your image on top of a plate. It's basically like a tabletop, so that when you set your plate on the tabletop is held up by four columns, or at least four. And the quadrants of the map, instead of the four corners, it's four quadrants, meaning, of course, north, south, east, west. And then you cover the whole thing with a giant crystal dome, which is the firmament, because all of that is located in a vast oceanic abyss, so that there's water above the firmament, and we're just this bubble of air. And so, and I apologize, I've got questions flooding in. So Axel, I cannot see that. Ax 11, I guess that says Ax 11. Kind of sucks. I'm trying to see. I need to blow that one up. Kind of sucks. He doesn't do more biological videos other than debating since a new series of plant group. Lycopsid saligana, who have the reproduction have the reproduction akin to, oh my God, progymnosperms, And also, these some of these words are strung together, so I'm having to separate them in my mind. Also, then is for answering. Oh, thanks for answering. It's all one word. Also, thanks for answering is all one word. So I'm having trouble reading that. Though since your earlier videos around Middle Paleozoic kind of got me dug into interest of plants by a whole prehistoric past. Yeah, I would love to do some more stuff about plants, but I've been focusing on vertebrate paleontology for so long. I mean, I branched out with some inverts, but going to plants is entirely new territory for me. So I don't know enough about it to speak intelligently. So that's why I've avoided it. Anyway, Keegan, I'm sorry, back to you.
Oh, yeah, fine, mate. It's interesting that came up because the next, I don't know what you call these tiers, maybe phylum Chordata. Do you have a spinal cord? Yes, then you're a chordate. Anything ever descended from a chordate mustn't necessarily be a eukaryote, an animal, and a chordate. And then the subphylum is vertebrata. Pretty self-evident. If you have a segmented spine, you're a vertebrate, and everything ever descended from a vertebrate must necessarily be all of these. These traits are part of the organism's ancestry and cannot be removed from its lineage. Those traits cannot be evolved out of. But you can lose traits.
Well, let's put a, because there's an exception to almost everything. Hagfish, and I forget the Latin name for these, secondarily lost their spine. So they're still chordates, but they're no longer vertebrates. Well, they're vertebrates in the sense that once you are the thing, you're always going to be classed within that class, because it's phylogenetics is based not just on what the characteristics that the organism has, but its evolutionary history. So hagfish are still classified as vertebrates, even though they don't possess vertebrae. They did, and in their embryonic state, they still do. Because there's an interesting thing about embryology. And I wish I could have gone back in time to explain this. It was Ernst Haeckel came up with this notion that phylogeny recapitulate, or what am I thinking? Ontogeny recapitulates phylogeny. Poetic, and if he had phrased it just a little bit differently, it would still be respected today. But he went too much into detail until it was wrong. So he suggested that organisms in their embryology, that they go through the adult versions of their evolutionary ancestry. And if he hadn't specified the adult versions, then he wouldn't have been refuted, and we would be still admiring and respecting his observation now.
Is that how they found out?
It's just there was was it not Ernst Mayr, von Baer. Von Baer, one of the first embryologists, said that no, it doesn't go through the adult forms. It only goes through their embryological forms. Correct. So the way you can see evolution happening in the embryological development of an organism, because it gets to the point where it would have diverged to become a fish, right? It's the same as what a fish embryo would start from, and then it moves on to where it would be what would branch into an amphibian or branch into a reptile. I'm putting it very simply. Of course, I'm putting it like in 19th century terms, but it's not the adult forms. And that was, if Haeckel had just not thrown the word adult in there, then it would still be respected today.
Is that how they found out about the hagfish? The only thing I know about hagfish is they produce copious amounts of mucus.
They knew about hagfish before they knew. Well, long before they knew that.
How did they know that they used to have a vertebrae?
Well, they used to be classified as invertebrates, and then they realized in their embryology that, hey, this thing has a spine in its earliest development, and it's an interesting thing. So if you look at the glass snake, which is not a snake, it's a legless lizard. But in the glass snake, as they're in their embryological development, they still have legs.
Yeah, well,
Hind legs. And then whales, of course, whales develop all 4 leg buds.
Yes. Yeah.
And then the hind leg buds just disappear as the embryo continues. Whereas if Ernst Haeckel was right, then that we would have fully developed legs before they're absorbed back in. But no, it only gets the leg buds. The genes turn on to develop hind legs, and then it turns off. Just like with chickens, have the ability to develop teeth.
Yeah.
And then you can trace these. You can trace the sonic hedgehog gene showing different types of development, and then it turns off, by the next week.
Because snakes they're classified as tetrapoda, right? When they don't have any limbs,
even though they don't have 4 legs anymore.
Yes, yeah. Because that's the next one. The next tier is superclass, which is tetrapoda, defined by creatures who have 4 limbs. And if you have 4 limbs, you're a tetrapod. That means all of your descendants are eukaryotes, animals, chordates, vertebrates, and tetrapods. And and I've put in brackets there, snakes and whales are tetrapods, though, with a question mark. So
along with manatees and a handful of other things.
Yeah, manatees even have fingernails, which is just
and elbows.
Do they?
Yep, they have elbows, which is they are the only. Yeah, there've been several times that animals have readapted to the sea, but in like every case with ichthyosaurs, mosasaurs, plesiosaurs, practically everything else, and whales and so forth, they're just like everything else, except for Meridia. I forget how to pronounce this. It's the only thing the only mammal that readapted to the sea that went extinct and has no surviving members. Meridiungulates, I think it is. They were the only ones that have elbows besides manatees. But manatees still have elbows, and also interestingly, their flippers have fingernails.
Yeah. On a round flipper was useless. Absolutely useless.
Absolutely useless. Yes. Now, a vestigial trait, because creationists will bring up this a lot. I mean, they want to say that there's no such thing as a vestigial trait because everything exists for a reason and everything has a function. But no, it doesn't. And that's not the definition. A vestige is just something that is reduced from what it used to be, so that its capacity in its original form is either reduced or eliminated. It can't even be the thing. It can't be used for the reason that it was anymore. It has to be readapted to something else or isn't used at all. And creationists will argue that everything that you can point to as a vestigial organ, they'll say, well, that still has a function. Well, that's fine. Yeah. Penguins still have flippers they can swim with. They're not wings. They can't be used as wings like they used to be. And their wings are vestigial too, because they can't be used as legs like they used to be previous to that.
An interesting bit of trivia recently that in the north, I think it was in the north region, that there was a class of birds called auks, AUK, and they were very similar to penguins, but they were completely different lineage, and it was an example of divergent evolution.
Mm-hmm.
Yeah, but they're completely extinct now, unfortunately.
Auks are completely extinct. I thought they were like I thought there was like there's the great auk or whatever, isn't it, like in South America?
I think there's, or maybe it was this one particular one that was
okay.
Yeah, it was quite interesting because they even look quite similar, but.
Yeah, so somebody asked the question, why did whales evolve out of the water just to evolve back into it? And that's a good question. That's Dylan Bly, 3468. In the case of whales, being very specific on that one, the forerunner of all of these, or the first whale, could be interpreted as, was still a land-based proto-artiodactyl. So we had I think that one still had 5 toes, but it's on the way to become the even-toed artiodactyl, but with cattle and giraffes and deer and that sort of thing. Most of the clove hooved animals, but while it still has, and it's already hooved, it's got a vestigial 5th toe, and it runs on these other 4, but it still has the 5th toe. And these, just instead of going on to be herbivores like the hippopotamus did, and a handful of other things that were so closely related to it, this is still eating meat, and it focuses on fish and seafood, and just it happened into using an aquatic and then eventually a marine environment for fishing. That was its way of getting around, and they developed heavier bones, and so that they had a more mass, so they would sink. I said more mass, so they would sink, but they had heavier bones so that they would sink, and they can prowl around, and they can take up the crocodile lifestyle, so they can burst out of the water to grab things on land if they want to. But in the case of whales, they generally use that for hunting underwater, eating fish and such. And then
the way they found that out was that creature you're talking about had a unique ear structure, right?
It had an ear structure like no other mammal other than whales.
Yeah.
It was a diagnostic of whales, and there's a handful of other things that were in line with whales as well, but nothing as diagnostic as the inner ear. What is the word? I'm not remembering. The auditory bulla. And then we have Deadhead 7878 says, how does the gene turn off? Well, it can be rendered dysfunctional in a number of ways. I'm not a geneticist, so I don't know all the answers to that. But one of them is, like a missense mutation will just simply turn that gene off. And that's what we ended up with as far as being able to produce our vitamin C. We need to get that from like citrus fruits, because us and other apes and monkeys lost that ability ages ago, and we all share that same defect. So you can find that defective gene throughout our primate ancestry. Did you? And that was the last. Wait. Nope, there's another one. So we have X11 8080 says, have you looked up the seed fern group, which might be very close to common ancestor of modern seed groups? I haven't done any botany. I'm completely unfamiliar with plants at all. So, I mean, if I'm going to be doing anything on plant life, I have to do a whole lot of research or have a tutor.
Have you finished your master's?
No, and I'm never going to be able to.
Oh,
I'm already in my 60s, and I am so taxed that
you're 60. Oh,
I'm
I thought you were
63.
like 50 or something. Yeah, right. Okay.
Yeah.
You're my dad's age. Okay. Right.
Yeah, and it's getting my degree while also I started doing it when I was still a single parent.
Mm-hmm.
And I would take a class or two when I could, and it took me a decade to build up the classes to finally get to the degree. A decade for a 2-year degree.
You should have just gone to the university that Coven went to.
Well, I guess it's technically a 4-year degree, but yeah, it still took me a decade to get it.
Just ask Coven where he got his.
I know where he got his. Mail order catalog. And then Life is Good, 12345 says, I love you. Thank you. Do you have a plan for a speculative evolution project? No, I'm not interested in speculation. I've seen some interesting things, some amusing things, but I find that the human imagination is limited, and our imagination does not ever catch up to what biodiversity can produce on its own, which is one of the big problems I have with intelligent design. Is that there are actual experiments that have shown in computer models of evolution that shows that natural selection is more creative than intelligent designers.
Well, we can't even do a very good job of imagining technology, like in Back to the Future, when they thought that the best thing was going to have 6 fax machines in their house.
Yeah, we never predict the future, like, at all. We get
No.
everything wrong when we do our predictions. But if you look at everything that humanity has invented, every animal that we've invented for our mythology or for our monster movies or space aliens, they're all based on something we've seen on Earth, and they're all kind of limited to that. I mean, like the xenomorphs are based on colonies of ants, and like Godzilla, even, what they and everything that we've invented fails to fit into any taxonomy. Every created life form, while they're all based on existing life form, they also fail to. The closest thing is the jackalope, because at least metamorphs are kind of closely related to deer.
Yes.
Yeah, that's as close as that gets. Everything else.
I'll tell you what, if you
that.
want a really good representation of someone who did a really good job of imagining a creature, is Project Hail Mary by the same guy who wrote The Martian. Has a fantastic idea about this alien that breathes different gases, and I'd really recommend it if you ever bored one day.
I like to see inventive stuff like that. There was a book, and I think they turned it into one of those CGI documentary things for science fiction on the investigation of the planet Darwin 4, and they tried to get really inventive with the life forms there, but they're still based on several of the life forms you could recognize. That you were thinking of an African pride lion when you designed this animal.
I know exactly what you mean. That's why I'd recommend Project Hail Mary for you, because they did a really good job. What was the last one we did? Tetrapods.
So everything that we've made up that we've invented for our fictional animals, they've all been based on something that we've seen in real life. They tend to be something that is a mix of different things. Like with Godzilla, for example, the original Toho Godzilla, that was a lizard that they mistook to be a dinosaur, but it wasn't just that. It was a lizard that had an external proboscis, external ears, and differentiated fangs. That does not fit in taxonomy.
Yeah, it's interesting that it has to follow a lineage, otherwise it makes no sense. Like if that appeared on Earth, would there be any chance to be able to go, okay, well, we need to go back, and there's obviously a lineage that broke off and we just completely missed it somehow? Would that be possible?
Godzilla is a whole special case because Godzilla is too ridiculously big to live.
Physics will take it down.
The transmission of ATP, just going from sending a brain signal to the muscles of its body, that alone, by the current structure, would not work. You'd have to rewire that. It would have to be like operated by light, something, light impulse or something like that. Because the attenuation in a common biological system, if you had a lizard or whatever, just grown to that size, there is no way that it would be able to function. Forget just having the fact that it would have to be quadrupedal, because you cannot have a biped that fucking big unless the entire outside of the structure, if the skin, the reason that Godzilla's skin is so mottled looking could be because its outer layer of its skin isn't so much skin as an exoskeleton, which is obviously also anti-ballistic armor, capable of withstanding high-speed impacts better than it can withstand low-speed impacts, which is why an equal-sized animal can punch him and do more damage than a missile can. Right. I spend too much time thinking about this.
I love it when you go on your tangents about Godzilla and your videos. It makes me laugh. Did you want to continue with this, or?
Sure. Well, let me see. Did I read the thing about? Okay, so would you ever consider producing more phylogeny videos once again? I'm working on one right now. I mean, I'm working on, the sad thing is I'm working on 3 scripts at once, but I mean, I have a good chunk of my next phylogeny video is already written, and that is on Dinosauria, because as the last video was on Ornithodira. And so I said, I've already done a video on pterosaur. Now I'm going to be doing dinosaurs. And I don't know that there is, I've never seen a video just on the phylogeny of dinosaurs. So needs to be one.
So when creationists say that man used to live alongside dinosaurs, I always laugh and say we still do because there are birds. Is that a correct statement, or should I stop saying that?
Well, yeah, but birds are dinosaurs, so yes, technically
Yeah.
we live alongside. But when people talk about,
I know what they mean.
I met somebody, a real nice person, and I agreed with her just about everything else she said. But when she said that people used to call dinosaurs dragons, and that dinosaur is a recent word, and previous to that, before they invented the word dinosaur, they called them dragons. I'm like, oh, this is a dark place. We don't want to go.
Mm.
You don't want to have this discussion with me.
Yeah.
Because dragon literally it's lizards.
Mm.
That's what the St. George's dragon was. That's most of the almost all of them, not quite all, but almost all of the dragon legends are based on lizards or snakes, both of them squamates. So we can say that the dragon sits there, and none of the people, if they had encountered an actual non-avian dinosaur, none of these people from the past that wrote all these legends about dragons, if they had seen a non-avian dinosaur, they would not have called it a dragon.
Mm.
That would have left an entirely different impression.
Yeah. Well, I've also heard the idea that the reason why so many cultures around the world adopted dragons into their folklore is because it was the three main predators against our ancestors, and it was birds of prey, cats, and snakes, and it's the amalgamation of all three, and that's why it's used in their folklore. Which
it depends on your folklore, but I mean, a lot of these, the word serpent is illustrative here because it applies to both lizards and snakes. So the whole serpentine thing, and a lot of serpents, a lot of it, like the Chinese dragon, for example, a lot of these, they take the form of a snake, but they still have legs for whatever reason.
Yeah, they're much more serpent-like in Chinese culture.
Yeah. Yes. But we've always had venomous snakes have been in everybody's folklore. That's where part of the legend of fire breathing comes from.
Yeah, I loved that video you did on the forked tongue, and it just kept getting more and more forks, because I didn't know until you made the video that monitor lizards are the only lizards that have forked tongues, and that's
not true. No. The tegu also has a forked tongue.
That red lizard over there with you, is that it looks like an iguana but red? Is that a tegu?
No, tegus are usually, they're yellowish or black and white. Marble kind of pattern,
but they have forked tongues as well,
and they're big, chunky things. They're quite different than monitor lizards, but on first glance, you probably wouldn't be able to recognize the difference if you're unfamiliar.
Yeah, we've got a few of them running around in the backyard now.
You have tegus?
No, goannas or monitors.
Okay,
yeah. So the next thing was class, Mammalia. Does your species produce milk to nurse offspring? If so, you must necessarily be a eukaryote, an animal, a chordate, a vertebrate, a tetrapod, and a mammal. So mammal has nothing to do with hair, with keratin strands? It's to producing milk?
No. I mean, it's if mammal was just based on hair, then tarantulas would be mammals.
Is that keratin, though?
I'm not sure about that. Yeah. I asked somebody this 2 days ago about whether the construct of what we call hair on a tarantula, is it actually hair like what we would see on a mammal? Because there are birds, and I had an emu for 3 years living in my backyard, that some of his simpler feathers, he still had pycnofibers on the top of his head. Hair. So it looks exactly like hair, but it's not. Under a microscope, you can see the difference, but you need a microscope to see the difference. So I don't know if there is a structural difference in what we call the hair of a tarantula or some other arthropods that are hairy, and is that the same as mammals? But there was we have mammals that are not. Well, they even whales still have a degree of hair.
Yeah, when they're younger, they have whiskers on their upper lip. Some of them, I believe.
Yeah, they're sparse, but they
Mm.
still have it, at least in the embryological stage. And then in their evolution, we don't call it a mammal until we note that deciduous teeth, the development of deciduous teeth, such that when an animal is born, it's toothless, which means it cannot live on its own unless it's ingesting milk from its mother.
God, okay, yeah. Speaking of vestigial structures, you had an emu. You saw the little dangly arms. That's something I point out to people a lot. I'm like, that doesn't even have a purpose at all. In fact, it's
Did you say that you had an emu?
Oh no, they just wander around here.
Okay.
Yeah.
I was very lucky to have it. Was one of my favorite. It was for years my favorite exotic pet that I ever had.
Yeah, I have my friend had a pet one, and it was very friendly. But yeah, just seeing those arms was just bizarre. A lot of people don't believe me until I point them out.
And you have to point them out because they're covered in the feathers and they're so tiny that nobody. If you make fun of T-Rex arms, but if you look at an emu, it's the same exact thing except it's one finger instead of two.
Yeah, but yeah, when creationists say there's no such thing as a vestigial structure, they have nothing to say about them, because that's literally what it is. It's obviously an arm.
That's been my experience too, and it doesn't have any musculature to move those arms. So what good is the claw on the end of that finger?
Yes, and if they get attacked by a dog or something, then they grip onto them. And then they get infected, and yeah, it's awful. So the next one was subclass Theria. Does your species give birth to live offspring? If so, you must necessarily be a eukaryote, animal, chordate, vertebrate, tetrapod, mammal, and a theriform. And obviously, there's platypus and echidna branched off prior to that.
Yeah,
because they lay eggs. They're monotremes. And I think there must have been a lot. I think in Australia in particular, monotreme and marsupial mammals thrived here because there were no real predators. But there's only 2 left now.
Well, I mean, the marsupials and the earlier, even the monotremes. Well, let's be more inclusive. Monotremata includes only the platypus and the 3 or 4 species of echidna, but it used to be that all proto mammals were egg layers, and some of these species included their own forms of predators like cynodonts and a handful of others. So they had the island mostly to themselves.
Yeah.
And I've suddenly got a flood of questions here. So Dylan Bly 3468, and I hope I'm reading that right. Is it true that crabs are the final form of crustaceans? That has been reported because crabs are polyphyletic. They evolved multiple times. So there's what we call a crab may not all have the same origin. So we do have crabs that all have a monophyletic origin, but then something else very crab-like independently evolves.
They call them true crabs.
I haven't done any serious research on this, but if I remember correctly, it's at least a half a dozen times that different things have become what we would call crabs. But then in the same sense of what we would call a lizard, we apply the word to everything that has 4 legs and a tail dragging behind it, everything that had that superficial shape, we would call it a lizard. If it's cold-blooded and scaly, and very often, and sometimes even when it's not. We just call it that grade. And so, next question. See, that is Johnny Nobody Knows Doe. Johnny Nobody Knows Doe. R and Ra, I've tried researching gorillas and their evolution, but the information about them is scarce. Is there anything, I guess that means, is there anything you know about gorillas' evolution? The fossil record is sparse for gorillas, and it's largely because of where they live. Jungle environments do not preserve fossils very well because of the nature of the soil. And that's why the biggest primate ever is known only from a couple of jawbones, and that's it, and a few sparse teeth. So Gigantopithecus was, again, a tropical jungle primate, and that's why we have virtually no fossils of it. No skeleton at all. We just have jawbones that are distinctly different from those of gorillas and orangutans, but markedly bigger than both, such that they can't even estimate the size of this thing, only to say that it's damn sight bigger than a gorilla.
I thought it was a really similar jawbone to an orangutan. When they depict them in media, they look like enormous orangutans.
It is classed as pongo.
Mm-hmm.
So, along with orangutans and Cebopithecus and Ramapithecus and others of that type. And then, but it is frustrating. We have more information on the evolution of chimpanzees than we have on gorillas, and we don't have much more on chimpanzees because, again, where they live, jungle environments just don't preserve that well. And then Axelvin 8080 says, what are your opinions on when Bilateria evolved and by extension Chordata? I don't want to answer that question because I don't value opinion a whole lot.
We value your opinion. That's why I come to you.
No, I get it, but I don't like speculation.
Mm-hmm.
I realize it's necessary if you're going to form hypotheses and then test them. You have to be speculative. But I don't see anybody's opinion being that valuable in this case. I would say that the development of Bilateria just makes sense. I was talking to a creationist friend of mine who that was his stumbling block. He couldn't figure out why something would have a mirror image version of itself in its genetic development, which seems so obvious to me. I mean, how efficient could it be if all it is periphery, if all you can do is create sponges?
What is it called? By what? Sorry?
I'm sorry?
What is this thing you're talking about? By what? Bilateria.
Oh, Bilateria.
Bilateria.
You have in the earliest eumetazoans, like the more advanced animals than sponges and whatever I'm trying to remember the other parazoan or I forget what the thing is called, but you get into things like comb jellies. These are animals that don't have any organs at all, but they're still more advanced than sponges and such. And then at some point, you have like cnidarians that have like maybe a top and bottom, but they have their symmetry is radial. So in a development, ideally, reproduction is going to settle on a radiation of some or a symmetry of some sort, because this is what our Hox genes are based on. You know, what segment of the symmetry these things develop in, all of that. So eventually, there's going to be some kind of establishment of a pattern that is productive, and that's the one that works better than this other thing did. So that's what they stick with. Just completely incidentally, without making any conscious choices about it. And with a bilaterally symmetrical organism, you have a front and back, a top and bottom, left and right.
Yeah.
So there's these three planes of axis.
If you look up humans on Wikipedia, it says that every human's face is actually squished to the left-hand side for some reason. I don't know how true that is. It was very scientific sounding, but
yeah, we're not perfectly symmetrical.
No,
you know, our liver is more on one side than our heart is. You know, that kind of thing.
Yeah,
but I mean, in our development, it's easier for the autonomous system to produce something that has a symmetry to its development. And one of the first ones was alternating isomers. And I wish I could remember what the name of this type of organism is. But it's interesting because creationists will always talk about how every phyla appeared all at once in the Cambrian explosion. And they do this very dishonestly, like they want to say that giraffes and birds and all of that sort of thing. Yeah, but really, not every phylum appeared in the Cambrian. There are two that already went extinct before the Cambrian began, and there's another that showed up after or right at the end of the Cambrian or right after it.
Was it also accompanied with a huge explosion in the amount of oxygen in the atmosphere, and that's what caused the Cambrian?
No, it really boils down to that two major lineages developed hard parts at the same time.
Okay, right.
So we have basically two different types of shells, but they're huge clades. So when they develop shells, well, now they just show up everywhere. You can see them. Where slug shapes in soft bodies don't fossilize very well, and you can find even bacteria fossils, but it required more technology than existed in Darwin's day.
Yeah, well, my mum's a geologist, and one of the most exciting things she ever found was a soft bodied starfish, because she said it was so rare.
Yeah, and somebody asked in these chats, what I don't think I answered is somebody asked, "What am I drinking?" So right now that's this local brew here in Dallas.
Was a stout?
Of course.
Yes. Was there any more questions there?
Oh yes, they keep popping up. All right, and let me see. And they're moving too, which makes it hard to read. Deadhead 7878 says Google says tarantula hair isn't really hair at all, and is something called
urticating.
I guess that's supposed to mean that's URTI. That must mean articulating hair, I would think. Urticating hair, and is different from mammal hair. Thanks for that. I suspected that would be the case, but I when I said it, I wasn't sitting at a computer. I was at a reptile convention handling tarantulas, and nobody knew the answer that was standing around me then. Then Johnny Nobody says, Johnny Nobody knows.
Though tarantulas.
Nobody knows dough. That's right. Tarantula hairs are made of chitin, not keratin. Chitin. Now that's interesting. That was unexpected. Okay. And then Dylan Bly 3468 says, that's why we find symmetrical faces more attractive. We like the DNA that was able to duplicate the best. Well, yes, of course. And while we are not perfectly so, this is a strange thing. I love this study. There was one study took all these pictures of high school kids that, in their yearbook, how they all have and they're basically all in the same face on kind of pose. So they feed these high school yearbooks into this computer that reads all their faces, it digitizes all their features, and then superimposes them, so that you get like that for all the girl class and on all the guy class, and you end up with these two perfect faces. They're completely average. They are the mean average of everybody in the school. But if that one person existed that was the average of all of them, that's an exceedingly beautiful woman. And since they didn't make distinctions for ethnicities, this exceedingly beautiful girl, the mass of all of the ethnicities in the whole high school came out looking like David Bowie's wife, the model Iman. They're just stunning.
Huh.
Yeah.
That was the last thing, wasn't it? That someone had written. Yes.
Okay.
Yep.
And I think it's interesting that the most beautiful girl is actually literally the most average.
Yeah. It's an interesting concept. I'll have to look that up, what you were talking about.
Yeah. So this has been well timed. I think we've been sitting at close to an hour. Did you say that you're done with all your questions?
No, there were just we can just go through them really quickly.
Okay.
So the next order was primates, which is if you have a high level of intelligence, grasping hands with opposable thumbs, nails instead of claws, with stereoscopic vision, developed to the detriment of sense of smell, belonging in all previously mentioned categories, you're very likely to be a primate. And then the next one was Hominidae. But if you walk up,
Hominidae or Hominoidea?
I've spelt it Hominidae.
Okay, that's Hominidae. So
Is
there's
that
actually they skipped one there. Well, they skipped a few actually,
okay? So with all the
because
primates and then
within
family.
primates you have you have the ones that, like, you have the strepsirrhines, which are like your lemurs, and they have wet noses like dogs, and they have like they have a 6 or 8 teats, again like dogs. But then you have
Terrible vision
you have
too.
the haplorhine primates, which are the dry noses, and so they're distinctly different from the lemurs. And these are like your lorises. And then within the haplorhine primates, you have a division, and I feel like I'm missing something, but you then have a division after that to get to anthropoids, also known, because there's 2 names for this one, anthropoids, also known as simiiformes, and that's literally the monkey clade. But anthropoidea, of course, means that it's human-like. It's hard to argue that you're human-like.
Yeah.
And in that one, you can have fingernails instead of claws, though not all of them have all of their fingernails and all of their digits covered in nails instead of claws. Some of them still have residual claws, but they'll have some nails. And then, so like the New World monkeys are actually older than the Old World monkeys, in the sense that when they diverged and ended up in the Americas, they retained more primitive features, and then what remained in the Old World developed more modern features. So they don't have any left over that hold on to the old features. So the New World monkeys still have the prehensile tail. They have the splayed nostrils and a handful of other traits, whereas the Old World monkeys have a reduced or weakened tail. It's no longer prehensile, if it's capable of anything at all, if it's even there at all, because there are some Old World monkeys that are not apes that also don't have tails. And then when you get in, there's a number of other features too. Their dentition, like in the Old World monkeys, is like ours, where the New World is different. And then you get into Hominoidea, which is the apes, and now they definitely don't have any tails. And again, their dentition is ours. And I completely forgot where we got color vision in there. That's at the base of primates as well. And then within the collection of apes, you have the great apes, which is the big ones. And in between the lesser apes and the great apes, you have a mid transitional form, which is the Dryopithecines. And where that was considered, when I got into these studies, that was considered to be a single species. That's now considered to be 50 plus species. And they're spread through the Africa, the Middle East, and Europe, with most of them being European, interestingly enough. And some of these developed into our current great apes. And then also known as the hominids, anything within Hominidae.
Yeah. So what's hominin?
Hominin means, when we mentioned that we have Gigantopithecus, Cephopithecus, Ramapithecus, and they're all in Pongo. Hominin is the great apes that are more on the human side. So gorillas, chimpanzees, and humans.
Okay. Yep. So the next, that was family Hominidae, genus.
And then when you get past the chimpanzee, then it becomes Homoine. So that's your Paranthropus, Australopithecus, Kenyanthropus.
Okay, right. Yeah. Because the next one was genus Homo. You're a human, correct? Assuming you can read this, I think it's fairly safe to bet that you are. In which case, neither you nor your descendants will ever give birth to anything but. And the list, and the final one was species Sapien. So genus Homo. So Denisovans and Neanderthals and that, are they all Homo?
Yep.
Okay, right.
So there are multiple species of humans.
Yeah. So
whereas now there is only one.
Yeah, because it went sapien, so that's sapien, that's us. anatomically modern human, neither you nor any of your descendants will ever or could possibly ever give birth to anything but for the last time a eukaryote, an animal, a chordate, a vertebrate, a tetrapod, a theriform, a mammal, a primate, a hominid, and a human, and an anatomically modern human. But we could branch into a new what are these gradations called? What would you call them?
In Linnaean taxonomy, those are called ranks.
Ranks. So a new
And
rank.
they don't work. They don't have any application anymore. Literally, they're largely abandoned. They're only used signposts.
Yeah. Look, like you were saying, there's so many exceptions. And I'm a complete layman, but I really found it really interesting that when you go down, you understand, because I really struggled to understand how things became new things, but they never lose what they were. You said something once that really clicked with me. It was about the fruit flies, and you were debating with Hovind, and you said, even if a fly develops into something that swims, it is still a modified fly. And that really stuck with me as well.
There's one more question I should develop. So this Ax11 8080 says, do you think we should use the term synapsia to be used to call mammalia alternatively, like how we call birds dinosaurs? No, synapsid is a huge group, and mammalians or mammals are just one subset of them. So synapsids includes dimetrodons and gorgonopsids and therocephalians and things like that were clearly not yet mammals. And then another one just jumped up. So it says, gay hat guy. Is that the Pope? Gay hat guy from Gotcha Game. Gotcha Game. Well, I'm not sure if that's, all these words are strung together. It makes it hard to read.
Yeah.
Microraptor was predicted by evolution. Yep. I don't get why you at some point talked about it as an intermediary of birds and dinosaurs when it came after true birds and wasn't ancestral to them. It came after true birds. So William Beebe in 1915, when they were doing studies of Archaeopteryx that had been discovered in 1861, William Beebe was an ornithologist, not a paleontologist. He studied birds, and so he's studying Archaeopteryx as a bird. And his problem with it was that it's not a bird. It's a dinosaur because all birds are dinosaurs, but Archaeopteryx is not a bird. It's extremely bird-like, commonly accepted as a bird, but lacks a lot of the diagnostic traits that all modern birds have. And one of the things that he realized was that Archaeopteryx had flight feathers on its hind legs. And he figured that and the wings on Archaeopteryx, he said, were undersized. So it would have had difficulty flying, and it wouldn't be able to fly very far or very efficiently. But the trick was, why does it have flight feathers on its hind legs? And then he realized that Archaeopteryx would be much more successful at jumping out of trees and gliding in a spread eagle fashion. Now, you can flap and you can get some more distance out of that, but you can actually achieve what they call flight, just not for very long. You're not going to fly south for the winter. But this meant that an earlier form that he called Tetractyrix would have had even smaller front limbs and more flight feathers on the back limbs. And this is what he predicted 100 years before Microraptor was discovered in fossils.
Didn't you say that?
It's upsetting that the people who had Microraptor was part of the Archaeoraptor thing where Steven Zerkis went to China and spent $80,000 on a faked fossil, only to find out later that it was a fossil of Yanornis and Microraptor and a couple of other things stuck together, literally glued together. And every paleontologist he showed this to said that it was a fake. Now they're real fossils, but they're real fossils glued together so that it makes a fake animal. And the thing is that one of the components of that was a hugely valuable find by itself. And if it hadn't been for the fact that he bought it as a fraud, we would have recognized what it was. And it wouldn't be called Microraptor. It would be called what William Beebe labeled it, Tetrapteryx.
Did you say that feathers originally developed are likely to help with warming nests?
Yeah. Well, insulation initially.
Yeah.
Because it turns out that dinosaurs were a lot more dinosaurs were warm-blooded, or a lot warmer than we thought. And even pterosaurs too. Pterosaurs and dinosaurs both share pycnofibers. So they're evidently, both of them were both lineages were at least partially warm-blooded, or mostly so. But in the case of theropods, where they're walking around on two legs, and so they have the two arms with these ridiculously long side feathers, creationists always often argued that there's no value in having half a wing. But in fact, there is. Because if you sit down on a clutch of eggs and you have these wing feathers on your arms, you can drape it over a much larger clutch of eggs much more efficiently, so that everybody gets equal temperature in the nest. Yeah. And so you are more productive that way.
It's like we were talking about before. They can't imagine the use for anything apart from what they know that used to be. That's why they struggle with vestigial structures and everything like that.
And even when they can imagine that, even when they can understand that, they're committed to a religious belief that, and a psychology that recent studies are showing that religion and political affiliation is largely determined by the type of brain development that you have, and the psychology that goes along with that. So that some people, and this can change as you develop. When you get older, things can be different than when you were young. But there's some people who are just psychologically adapted to that facts override everything. That's me. If you can show me the fact that I'm wrong, I don't have a choice to believe otherwise. I have to accept the reality that I am wrong, and then change my position accordingly and continue on. But other people have a psychology that loyalty to the in-group matters over everything else, including fact. So when you prove that they're wrong, they will continue to believe that they're right. And anything, it'll actually cement their position. And this is what causes them to vote against their own rights.
Yep. Met lots of people like that.
Yeah. And it cannot be reasoned with. It's not just that they won't be. They lack the comprehension to be able to question their own position, even when you illustrate them.
Yeah, it was like talking with flat earthers or something like that. They're so incredibly smug, and they think that when you get frustrated and angry, that means that they've touched on a nerve with you, but they're just infuriating to deal with.
I just don't like liars, and I don't suffer fools. So, and I'll have infinite patience if I think you're sincere and just confused or stupid. But it's when you are visibly lying at the same time, then it's off.
It's called bad faith arguments, where you can actually tell they don't actually believe what they are actually saying.
Yep, exactly.
Yeah.
So, all right, that I think satisfies it.
It does.
All right. Well, I want to thank you for this this invitation. Let me see.
Thanks for having me on.
All right. It took me a minute to figure out when you said, "Hey, let's do another hangout." I had to try to figure out, am I on your channel? Are you on mine? I had to go look.
Oh, sorry. It's all good. No good. I'm glad we finally got to it, because we'd had a couple of screw ups there.
Yeah, that's me.
No, it's all good. I understand you're busy, so it's not a problem.
Yeah, and the last time, if I remember right, I thought that we were going to be done with this thing by this time, and so I'll be able to, within a half hour, I'll be able to, and then the thing went on like an extra hour longer than I thought it was going to be, and there was no way out of it once I'm in.
That's no problem. It's really no problem. I know you're good for it, so it's no issue. Thank you very much.
Thank you very much, sir.
Talk to you next time.
See you soon.
See ya.